Hello, hello, I hope you can hear us. We are currently driving from Santa Cruz to Funcaliente in the south of La Palma, and we want to enter the exclusion zone from the south there. And we are trying now to make use of the travel time by having a little chat. We got some questions on YouTube about the relationship of the Canary Islands to a mantle plume. And to my mind, the discussion is largely resolved, but it seems there's some people out there who still have issues with the mantle plume theory. So, Juan Carlos, can you tell me a little bit about the early ideas on the mantle plume? Because there was these two models, the Plume model in the 70s and the fracture model.
Yeah, actually there were three.
There were three? Okay, go on.
One was the fracture related to the Atlas Mountain fault system. The second was a block, differential block, with the volcanism in between the blocks. That was very early retired, let's say. The competition was actually between a plume, deep mantle plume, and the fracture related to the Atlas Mountain.
And what is the reality today? I mean, how can we be confident that the Plume model is the superior model for the two?
Well, there is a very good reason. There's a geochemical reason that there is some kind of isotopic composition of the magmas that have to be related with a deep mantle source.
I think so. I think that's correct. We have a very clear signal from the chemistry. This way, okay, thank you. From the chemistry that this is an OIB type magma, an ocean island basalt type, and that's very different to fracture-related or rift-related lavas that are more mid-ocean ridge type. We should switch that off, maybe, at least for now. And
exactly, the magmas related to fractures are completely different composition.
Yes, that's one thing. The other thing is, of course, there's geophysical evidence.
There's geophysical evidence of the seismicity, but also there is a very important thing, is the age progression that is related to mantle plume.
That's
because
right.
It's a mantle plume that is supposedly is static for a fixed for millions of years, and is the tectonic plate that is moving on top of the plume. So you get a progression, an archipelago that is progressively older islands. The farther they get from the mantle plume.
Yes.
And this is a very powerful.
And that's very kind of different in the fracture-related systems,
exactly.
Like in the Cameroon volcanic zone.
Exactly. Whereas in the volcanism that really is related to the fractures, age progression is not necessary, and it doesn't happen. And this is because there are 4 Macaronesian archipelagos. The Canary Islands, Madeira, Cape Verde, and Azores. And Azores has happened to be in the triple junction of the Azores.
Yes.
So it really is a volcanism that is fed by a mantle plume, but at the same time is on a fracture. And then there is the same composition of magmas, a plume-related feeding system, but no age progression.
No, the Azores seem rather randomly in terms
exactly.
of age, and this is also what we see in the Cameroon volcanic
In the Cameroon volcano, exactly.
The ages are rather random and not systematic.
Also in some Pacific archipelagos.
Yes. So, while Hawaii and of course the Canaries and also the Cape Verdes, they have an age progression.
Exactly.
And that's a very strong evidence, and this is where our fossil evidence from 2011 from the El Hierro eruption was very important, because we could show that the xenolith, they had very young fossils, comparatively young fossils.
Exactly.
And this means that the sediments underneath the island of El Hierro were very young, and therefore it confirmed that not just the eruptive rocks on the island, but also the sediments underneath the island were very young, implying El Hierro is the youngest.
Because when an island starts to grow, it's like putting a cap on top of the sediment. So this prevents more sedimentation.
So let's quickly go back to the geophysics, because some people might find that interesting. There is this method, seismic tomography, that allows you to image any anomalies down up to the depth of the mantle. And there was the work by Montelli and others some little over 10 years ago. And they imaged anomalies under the Azores, under the Cape Verdes, and of course under Hawaii, but also under the Canaries.
They use a very simple technique, that is using the big seismicity in the world to make a seismic tomography, because the hotter the mantle, the material is, the less the slower the seismic waves propagate. And so they can make an image that is real, instead of the normal light we see is making with the seismic waves.
And this anomaly continues virtually all the way down to the core mantle boundary, not quite, but almost. So this is a deep plume. I mean, this would not be the case if this was a near surface fracture.
Exactly.
The Atlas fracture could not go down that deep. I mean, the Atlas fracture is a surface feature. And of course, there's the next problem. Nobody has actually imaged the Atlas fracture to continue offshore.
Absolutely. Probably, I remember that a friend told me that for the first time I learned this lesson, that when a fracture propagates from the continental crust to the oceanic crust, it's like trying to propagate a fracture from wood to the iron.
To metals, yeah.
To metals. So actually, when something like this happens, the fracture propagates in the interface between the continental and the oceanic plate.
This is very true. I mean, we also know that from dikes, when they go through different strata, they often get distorted or get stuck or things like that. So
they either arrest or they adapt to the...
To simply draw a line that might work on a map, but that's a bit challenging. It's not. It's a fundamentally different rock type there. It's continental versus oceanic systems. Oops, our camera just fell, so we'll have to put it back up. We are improvising, as you can tell. So
we can resume saying that the Canary Islands, Cape Verde, and the Madeira are islands that are independent of the lithosphere.
Yes.
Whereas Azores is also a mantle plume that is related to fractures.
That's
and they behave completely
fundamental
different.
And there is a...
The shape of the islands in the Azores are like, how do you say?
We're on a hillside with a digger in front of us right now.
Are completely linear, parallel to the fractures. Whereas the Canary Islands is rounded.
Yes, that's true. And there's one more fundamental issue, and that is the Azores have, because of their fracture origin, they have a lot of intense earthquakes.
Yeah.
And there is very few earthquakes in the Canaries, generally speaking. And they're also rather small, comparatively speaking. Yeah. All plate boundaries are really riddled with earthquakes, and this is obviously not what we see here. The final point before we close, and before the telephone falls over once more, is there is this idea of a fracture that goes through the Canaries between Gran Canaria and Tenerife. And what's your opinion on that? Because that's a bit controversial, at least from my perspective.
Yeah, it's good news, because imagine that we have a real active fracture with potential the capability to produce, like in the Azores, earthquake of even 7 and more than 7 in the Richter scale. This is catastrophic.
Yes, that's fortunately,
since in the Canary Islands the real engine of seismicity is movements of magma, the earthquakes are reduced or have a limit, and the maximum earthquake ever recorded in the Canary was 5.4.
That's a
And
very clear
this
indication.
is very good news.
Yes. And there is, of course, seismicity in between Tenerife and Gran Canaria. This is because there's a little volcano growing
Exactly.
in between.
There is a field, a volcanic field, and there is a volcano that's called, well, actually, the German people named the volcano the son of Tenerife.
Hijo de Tenerife.
Hijo de Tenerife. Whereas now the Canary people call the volcano in between, because in between
Intermedio.
Tenerife, intermedio.
Because then
Between Tenerife and Gran Canaria.
the rivalry between
But
Gran
anyway,
Canaria
it's a
and
volcano
Tenerife.
that has been sampled, has been photographed, and it's a real volcano.
Oh yeah, I've had samples. I actually have samples from it.
And it's easier to understand a long-term seismicity related to an active volcanic zone, submarine of course, than to a fault that has another type of seismicity completely different.
Okay, great. I think we've covered the key evidence. I mean, if there's questions, people can leave some comments. So, and now we're going on to some bumpy road here, so I guess we'll better stop. So, thank you very much for tuning in. Thank you, Juan Carlos, for discussing this with me. And I guess
For more questions, they can consult our Geology of the Canary Islands,
and of course
published by Elsevier.
our encyclopedia article,
And it's
we actually have that here, and I'll put a link into the text box below, so you can actually get.
This article is specifically related to the origin of the Macaronesian archipelagos.
So, and there we discuss all these evidences, and now I really think it's enough. We are on this bumpy kind of road here, so I'll say goodbye and all the best.
Bye-bye.
Good luck.